Today we are going to see how to calculate shape factor for T section. Here you can see a T section is there consisting of flange 150 by 10 mm and web as 200 by 10 mm. We'll start with the solution. Here in the next diagram in figure 1A and figure B you can see axis has been drawn for plastic and your normal centroidal axis. Okay, here this diagram figure B we are going to use for calculation of elastic moment and this is for plastic moment. We'll start with elastic moment. Formula is given by Fy into I upon Y max. The very first step we'll first see how to calculate Y max. Okay, now first we are going to calculate distance from top edge. Okay, formula is given by a1 y1 plus a2 y2 divided by a1 plus a2. Area we are going to calculate first. You can see in the diagram. Okay, so area of this T section will be 150 into 10 plus 200 into 10. Just solve it. We'll get the value as 3500 mm square. After that, now we'll calculate centroidal distance from the top edge. So it will be this distance. If you'll see this diagram, for what is formula? a1 y1 plus a2 y2 divided by a1 plus y2 a2. Here we'll calculate from top edge. You can also calculate from bottom edge. From either one side you can calculate it. Okay, I have calculated from top edge. Here you can see now a1. Okay, a1 will be flange area and a2 is nothing but your web area. So a1, this is 150 into 10. Okay, divided by center of this. Okay, this top distance we are calculating from top. Okay, so from this top line till center of this flange is nothing but y1. So it will be, what is total distance of flange? That is 10. Okay, we are calculating from top, so it will be 10 divided by 2. The same thing is written over here, plus second web area will be 200 into 10. Okay, now we want distance from top, so it will be, what will be the centroidal distance for this web only? Okay, total height is 200. So exactly center distance will be 200 divided by 2 plus we are calculating from top. So this 10 should be added in that. Okay, so total y2 distance will be 200 divided by 2 plus 10. Okay, and divided by a1 plus a2. Area you have already calculated it. Just substitute the value. You will get the value as 65 mm. Okay, so centroidal distance from top end or top edge is given by 65 mm. So what will be bottom distance? From bottom, what will be distance? Total distance is this 200 plus 10. So total distance is 200 by 210. So 210 minus 65 will give you the bottom distance. Okay, so what will be? Okay, so therefore Y max value will be 145 mm. Next is to calculate I. In formula you are having I term. Okay, so first we will calculate I. Okay, formula is BD cube divided by 12 plus AN square. Here you can see the diagram. Now first we will calculate for this top flange. Okay, so B, what is B? 150. What will be D? 10. So 150 10 cube divided by 12 plus AH square. What is H value? From your actual centroidal axis till centroid of this flange will be your H value. Okay, so area as it is, so 150 into 10. What will be H now here? Okay, so the top distance you are having as 65 mm. Okay, centroidal. Okay, this center line of flange. Okay, so what will be center distance? That is 5. Okay, from top also 5 and from this bottom also 5. Okay, what distance we want from neutral axis? Your actual neutral axis. Here you can see in green color, that is your neutral axis. So what will be distance from neutral axis till the neutral axis of this flange? It will be 65. Just subtract this 5. Okay, so 65 minus 5 will give you 60. So h value is 60 over here. Just substitute that value, that is 60 square. Next is for web. Here you can see formula will remain same, BD cube divided by 12. So B over here is 10, D is 200 cube. Okay, this height is 200. So 200 cube divided by 12 plus area as it is 10 into again 200 into h square. Now here h will be center of this web. Okay, total height is 200. So what will be center height? That is 200 divided by 2. So it is 100. 100 plus we are calculating it from neutral axis, means what will be h distance over here? Okay, neutral axis of this web and neutral axis of complete T section. The distance between them is nothing but your actual h value. Okay, so from top we have calculated. So this is 200 divided by 2, so 100 mm plus 10. So from top total distance will be 110. Okay, so what will be h? This is neutral, green color is nothing but neutral axis of complete T section, and this black line you can see, that is neutral axis of the web section. So distance between these two is nothing but your h. So it is total height 110 minus 65 will give you h value. Okay, just substitute it and get the answer. Okay, now you have done with I and y max. Just substitute and get the elastic moment value. Okay, you will get it as 111,235.63 into Fy. Next is plastic moment. Okay, now for plastic moment also steps will remain same. First is here, first diagram we can see. Okay, this is your plastic neutral axis. Now there is need to calculate first y1 and y12. Okay, here you can calculate it directly, no need to use the formula, because in plastic analysis we make the assumption that area of compression is equal to area of tension. That will be exactly half of the area, that is A by 2. Now here we will consider bottom area. You can also consider top area or bottom area, any area you can consider. Now here bottom area will be easy to calculate. Okay, so area of tension, that is nothing but area of tension. Okay, so what will be area of tension? What we want actually, this y1 and y12. Okay, we are going to equate. Now area of tension, what will be area of tension? That is equal to A by 2. Area you have, complete area you are having of T section. Okay, 3500 you have calculated. So this area, bottom area will be this 10, web thickness is 10 into y2, that is equal to A by 2. We are going to equate it. Okay, the same thing is written over here. 10 into y2 is equal to 3500 divided by 2. You will get y2 value. Okay, and just subtract 210, you will get y1 value. Next step is to calculate plastic moment. Formula is Fy into A by 2 into y1 plus y2. Now here purposefully it is written y1 double dash. What is y1 double dash actually? Your actual neutral axis. Which neutral axis here you are going to consider? Plastic neutral axis. Okay, so distance from that neutral axis till centroid of the top portion is nothing but your actual y1 double dash, and y2 double dash is nothing but from neutral axis, that to plastic neutral axis, from plastic neutral axis till the centroid of the bottom portion. Okay, that is nothing but your actual y1 dash, y1 double dash and y2 double dash. Now here you can see separately we'll draw the diagram. Here you can see the plastic neutral axis is already drawn. Okay, now we'll calculate this centroidal distance, same as that of first part. Okay, distance from top edge we have calculated in the first step for complete T section. Similar, same formula we are going to use over here. Okay, formula is a1 y1 plus a2 y2 divided by a1 plus a2. Okay, so what will be a1 over here? 150 into 10. Okay, from top we are calculating. So what will be y1? It is 10 divided by 2. Next is a2 will be, it is thickness is 10 and height is 25. So 10 into 25 into, so center of this web, 25 divided by 2, as we are calculating from top, so 25 divided by 2 plus 10 should be added in that, and divided by area of this. Okay, here area will change, only we are considering area of above plastic neutral axis. Okay, so that area should be considered. So it will be 150 into 10 plus 25 into 10. Okay, it is 7.5. From which end? From top edge. What we want actually, this bottom distance, that is y1 double dash we want. So what will be y1 double dash? It will be, just subtract it. Okay, total height is 35. So 35 minus 7.5, that is 27.5 mm. After that, y2 double dash. Again, we'll draw the diagram below the neutral axis, plastic neutral axis. Okay, so here only one web is there. Okay, so no need to use the formula. Here you can directly solve it. That is 175 divided by 2. That is 87.5 mm. After that, all values you are having, just substitute in the formula of plastic moment, that is Fy into a by 2 into y1 dash, y1 double dash plus y2 double dash. Okay, just solve it, you will get it as 201 250 Fy. After that, shape factor for T section is given by the formula plastic moment divided by elastic moment. Just substitute the values, you will get the shape factor as 1.809. Always remember that shape factor is never greater than 1. Okay, means it is in the range of 1 only. Thank you.